Alright, morning. So it is the end of August now, coming to the end of my internship between Great Ormond Street Hospital and Roche. So Great Ormond Street Hospital, or GOSH, is a kids hospital in London. Roche, big pharma company, multinational, offices everywhere. This is the fourth of a 5-year collaboration between the two, and I just joined for this summer. It's really amazing to see up close, honestly, because my career mission is to build out this NHS plus pharma model, and I really think there are a lot of ways that these industries, like a nationalised healthcare system and kind of the frontier of medicine in pharma, can interface with each other and interact with each other, complement each other. And yeah, just getting to see up close has been really invaluable experience. So what I thought I'd do is just take you in for one of my final days, show you around the office a little bit and give you some insight into the work I've been doing. So yeah, come along for that. Okay, so I'm in GOSH at the moment. It's the morning, it's quite early. Thought I'd come in here into this alien pod that I'm sitting in to record this so I don't disrupt anyone else. The data sets that we get are unique in a multitude of ways, right? Like you just naturally have smaller data sets because there are fewer kids than adults. You also get really variable biology because kids have like their own type of biology, and a lot of standards we have around medicine are based on adults rather than kids. So you have like this really, really tough problem, right? Small data sets, kind of a lack of precedent for how to deal with kids, or less of a precedent, I should say. Combine that with very variable biology, and it's quite a tough problem regardless of the data set that you have. What I'm working on specifically is medical reports from histopathology images. You'll get a patient that comes in, the doctor will take some sample from them, they like remove a bit of the tissue or whatever it is. So maybe the clinician suspects that the kid has a kidney tumor, so they'll take out a bit of the kidney. They'll then stain that kidney with these chemicals, take an image of that under a microscope, and that gives you the sort of characteristic pinky, purpley, off-white image that you see here. And then from that they write a report up. That's what I'm working on. And then the final diagnosis of that report will be used to do the next step of treatment. My aim is to just extract all that key information, like the summary basically of what they're reporting there, removing all the noise basically from the report. Point of this as well is like we don't have large, like huge language models, right? Because it's the NHS, it's private patient data, you want to keep it secure. That means that we have to use smaller models than you'd use in like maybe a big tech company or something like that. Because they're smaller models, they can be a bit less reliable at times. You basically need to develop an intuition about how that model works. Think about the input you're giving to that model, and can you add some guardrails to it? Can you help standardize what's coming out of it? I'm gonna go back to my desk, try and get the most annoying work out of the way. And for me today, that's reading through a bunch of reports, reading through a bunch of outputs from my LLMs. This is the grunt work, but this is arguably the most important work, right? You need to check the LLMs, make sure that they're doing what you expect them to be doing. No point talking about it, let's just get to it, and then I'll be back later on. Yeah, so for the oncology work at the moment, just managed to finish running all of the reports like as of today. So hopefully, like I presented the initial reports for like half the data set, can now run it over the entirety, start writing that up into the final report. The actual cancer itself is so dynamic, like you get so many rare cancers, there'll only be like, at most like 1 or 2 reports of them in the entire data set of like tens of thousands. There's no real way that you can design a model for something like that, right? Like you just have to read it. I just need the model to tell me, okay, this is a rare cancer, get a human to read this. Like there's no way of kind of automating that. With cancer, it's so broad in terms of the diagnoses you can get. So many different types of cancers, all these dynamic elements to cancers as well, like they can metastasize, so they go from one area to another. I've been dealing with this a lot with things like neuroblastomas, which are brain cancers, but they can metastasize to like bone marrow, for example. The whole like idea of cancer itself, right, is that you have these malignant cells inside of you attacking you. It's not just the tumor cells, the malignant cells itself, it's the tumor microenvironment, the tissue and the blood vessels around those malignant cells as well. Because what cancer does is it learns to kind of feed off the stuff around it. Just that idea of how complex that biology is how dynamic it is, it just makes this like a doubly hard problem. In addition to all the things I was saying before about, you know, pediatric settings, so smaller data sets, very variable already. We do make it fun for ourselves, don't we? It's not always the easiest problem, but I gotta say, like, it makes it quite a good learning experience overall, because you get to work with so many different people, like pharma people, clinicians, data science people, project managers as well, comms people. You can be working on a problem for like a month, and then you speak to a clinician and they'll just solve it for you in half an hour. Swear to God, like they just have an ability to really get to the heart of a problem very quickly. It makes sense to kind of have this collaboration where you could put money towards things like, well, I think this collaboration is around digital tools, it's around like building up a set of like ways of working for how pharma can collaborate with the NHS, which as far as I'm aware hasn't happened a huge amount of times. You know, like I was reading this report from the King's Fund, who are a big, I think they're a think tank, like a healthcare think tank in the UK, and there's only been like 4 other big cases that they reported on. I'm sure there have been other smaller cases, but you know, it's just cool to see like how the incentives can kind of align for projects like this. You know, one thing that would speed up this workflow a lot is having a bit more compute. And you know, just as of last week, GOSH managed to get some GPUs in, which are these high performance processors that allow you to run AI models more quickly. We were seeing some like ridiculous speed ups as well. And hopefully we can get more of these GPUs into NHS Trust, because I think there's a lot of data there. A lot of data that, if it's standardized and run through good quality models, a lot of insights that can be used to improve patient care. It's just gone 5 p.m. and I'm going to head home. Don't think there's anything more to say. Kind of gave you the recap already. But yeah, thank you for watching. And keep an eye out for GOSH's work. I'm sure there's plenty more coming. Peace.